Many years ago, Swagelok tube fittings were put through a severe thermal shock test at an oil refinery facility in Ohio. The classic film, Ohio thermal shock test, is still a dramatic representation of a rigorous tube fitting test. These film clips illustrate the temperatures, pressures, and stresses our tube fitting connections withstood throughout the complete test with absolutely no leakage. Since this original test was filmed, Swagelok Company has been driven toward continuously improving the Swagelok tube fitting and validating it in a wide range of extreme tests, many of them conducted at third-party facilities. The following will demonstrate some of these tests as they were conducted. A third-party lab conducted a burn test to ASTM F1387 requirements. Testing was performed on 1-inch stainless steel Swagelok tube fittings at 3,000 psig nitrogen pressure. The temperature was rapidly elevated to 1,700 degrees Fahrenheit and held for 30 minutes. As the video illustrates, the fittings and tubing turned a bright red color due to the heat, while maintaining a leak-free connection, as confirmed by a pressure gauge. After 30 minutes, the oven was turned off, and you can still see the fittings glowing as the oven cools. A final gas test was conducted after the assembly had cooled, which the fittings passed with no leakage. Another burn test was conducted on stainless steel Swagelok tube fittings to the requirements listed in the American Petroleum Institute, or API 607 specification. Direct flame was pointed toward the fittings from multiple burners for a time period of 30 minutes. The pressure inside the assembly was 2,500 psig water, which turned to steam. After 30 minutes, the assembly was quickly quenched in water. API 607 allows a 5-minute delay between flame shutoff and start of quench. The final proof test after cooling was conducted with 2,500 psig water. The Swagelok tube fittings passed. Another test that was conducted at the Swagelok Company product lab included a combination rotary flex and impulse test. A 1/2-inch Swagelok male connector was assembled on tubing, then attached to a stationary block. The other end of the tubing was attached to a fitting, which was then attached to a rotary wheel. The wheel has a prescribed angle of deflection and is set to create a specified stress level. The wheel rotation is quickly increased to a speed of 3,500 revolutions per minute. The assembly also impulsed from 0 to 1.5 times working pressure, or almost 5,000 psig, over a 1-second time frame. The overall test is 10 million cycles on the rotary wheel, which takes approximately 3 days to complete, or 500,000 impulse cycles. The Swagelok fitting successfully passed this test with no fitting leakage or tube fracture. Another third-party facility conducted a shock impact test on 1-inch stainless steel Swagelok tube fittings, also to ASTM F1387 requirements. The fittings were assembled and placed in a fixture. A 400-pound weighted hammer was dropped onto the assembly fixture from heights of 1, 3, and 5-foot elevations to simulate the effects of depth charges on submarines. The hammer drop sequence was repeated from multiple angles on the fitting assembly. This video details the amount of impact or side load the Swagelok tube fitting withstood, yet no leakage was detected during the pressure test after the impacts. Due to the application of subsea operations, Swagelok Company designed a unique test rig for the purpose of analyzing external pressure on a fitting assembly. A tube fitting connection is placed into a chamber, and the chamber is filled with water. The chamber is then pressurized so that the assembly experiences external pressure, similar to what an assembly on an offshore oil platform would be subjected to, as it is lowered thousands of feet into the ocean. The external pressure is then increased until the tubing wall collapses under the extreme pressures. No leaks. A tensile pull test is used to demonstrate the effects of unsupported weight on tubing and fitting connections. This test is being conducted on 2-inch stainless steel Swagelok tube fittings at our Swagelok product test lab. The weight load is increased by pulling each end of the tubing at a rate of 1/4 inch per minute. The test is designed to compare the maximum load that the tensile pull reaches before the tubing is forcibly pulled from the fitting. This assembly reached a load of over 45,500 pounds, which is the equivalent of 14,465 psig, well above the American Society of Mechanical Engineers' calculated burst pressure of 13,500 psig for 0.188-inch wall thickness tubing. One of the classic Swagelok tube fitting tests is the hydraulic burst test. Shown is a 1 1/4 inch tube assembled to a Swagelok tube fitting. The pressure is applied gradually until the allowable working pressure of the tubing, 3,200 psig, is reached. No leaks. The pressure is then increased in 1,000 psig increments until the tubing yields, and finally burst occurs, demonstrating the integrity of the Swagelok tube fitting. Another modern tool that Swagelok has incorporated into its product test portfolio is finite element analysis, or FEA, which assists our engineers in modeling stresses and loads. FEA is a computerized mathematical technique that depicts the effects of elastic and plastic deformation on materials, such as stainless steel. It allows Swagelok to more comprehensively look inside the fitting integrity, far beyond actual field test applications. This pull-up of the Swagelok tube fitting, as it is depicted with FEA modeling, demonstrates the hinging, colleting action of the back ferrule. FEA was instrumental in Swagelok's development of the advanced back ferrule and SAT-12 hardening process because it allows its engineers to model the effect of any changes before parts are made or sent out for test. This commitment to continuous improvement enables Swagelok to use the most advanced methods for providing exceptional product performance in the most rigorous tests, so customers can continue to receive value beyond the expected.